Perishable monitoring using smart sensor tags. A far-fetched futuristic idea, or within reach of tomorrow's industry? In the supply chain of perishable products, such as for strawberry, all partners involved do their utmost best to bring a high-quality product to the end users, being you and me. In spite of these efforts, a large amount of the products produced gets lost somewhere along the chain and never gets consumed at all. According to recent figures of the Food and Agriculture Organization of the United Nations, this can get as high as 50% of the fruits and vegetables produced. The European PASTEUR Project aims to provide technical means that can help to reduce these losses by developing a wireless sensor platform to monitor the environmental conditions throughout the supply chain of perishable goods. By identifying the weak links in the supply chain, the industry can much better focus their efforts in reducing waste. In the PASTEUR project, a European research consortium of academic and industrial partners have combined forces to develop the concept for such smart sensor tag. The technology for the wireless smart sensor tag requires small, cheap but accurate on-chip sensors that can monitor the most important environmental conditions relevant to perishable fruits and vegetables. Temperature is a main factor affecting the rate of quality loss and thus limiting shelf life. Humidity is a second main factor, as at too low levels it can induce wilting and saleable weight loss, while at too high levels it might induce rot. Gases like oxygen and carbon dioxide play an important role in storage and packaging by inducing a state of hibernation. Finally, ethylene is an important natural gas to monitor, as it is an indicator of the ripening state of many fruit products. Besides the sensors, other supporting technologies are required to make things work. Printed batteries have been tested to provide the tag with enough power for several weeks. A microprocessor has been designed to integrate the sensors and to house algorithms that process the data. An on-tag antenna was integrated to guarantee wireless communication with the outside world. Intelligent algorithms were developed and embedded in a graphical user interface to translate the multivariate sensor output into easy-to-interpret predictions of product quality and remaining shelf life. Strawberry is a delicate, highly perishable product requiring lots of care and attention, starting at the grower's place. Only high-quality product is selected to be picked, packed and prepared for the auction. Proper cooling is essential to quickly remove field heat from the product. The auction centralizes product streams coming from many small and big producers. It is their responsibility to control incoming product quality and to provide the retail with a continuous flow of product of a consistent quality. Keys to a successful supply chain management in the perishable industry are rapid turnovers and tightly controlled environmental conditions in all links of the chain. Retail relies on the auctions to provide them with high quality product to satisfy the consumer. However, depending on all parties involved in the supply chain, the quality of chain control might vary. This involves the individual growers, auctions, transporters, distribution centers and retailers. Their concerted efforts accumulate in the quality of the product finally presented to the consumer. This is where, once commercialized, the wireless sensor platform from the PASTEUR project will make the difference. The sensor platform can be commercialized as a cheap, disposable, credit card-sized tag. Tags can be instantiated and assigned to a batch of product at the grower's place. Depending on the application, this can be done at the pallet level or at an individual crate level. At crucial points throughout the supply chain, data can be read from the tags and stored in a centralized database. In case of non-conformances and at the end of the supply chain, full sensor data can be downloaded from the tag, stored and analyzed to facilitate troubleshooting. This data will provide a detailed overview of anything that happened between farm and fork. Communication with the smart sensor tags is available through a web-based graphical user interface. It allows the user to instantiate tags and link them to the relevant administrative data. By communicating through the reader, nearby tags can be identified and interrogated. The smart sensor tag contains a statistical control model. This model quickly identifies any non-conformances following product-specific limits for the conditions monitored by the sensor. This will result in an on-screen status flag. In addition, the smart sensor tag contains a generic shelf life model that calculates dynamic best before dates based on the actual conditions incurred by the product to date. This is presented in a graphical user interface as the number of days of remaining shelf life. In the case of non-conformances or limited remaining shelf life, full sensor data can be downloaded, stored and compared with historical data available in the database. The interface software finally provides added intelligence in the form of algorithms that predict product quality based on the sensor data. In the case of strawberry, this covers weight loss and the incidence of rot. This facilitates interpretation of the data in terms of its effect on product quality. While the PASTEUR project has explored the technical possibilities and limitation of a wireless sensor platform to monitor environmental conditions throughout the supply chain, it is now to the industries to take it through the next steps of developing a commercial product that is ready for industrial implementation.